Hi everybody and welcome to lesson 63. My name is Danielle. Now you may have joined me in lesson 62 when we explored faces and surfaces on three-dimensional objects. We identified and compared the number of faces and surfaces on a variety of different three-dimensional shapes. Now, we have been using some different mathematical language in the last few lessons. We've been talking about faces on a three-dimensional shape, being a flat surface of a three-dimensional shape, and three-dimensional shapes are enclosed by surfaces which are either flat or curved. Now we've got some new words that we'll be using today: corners and edges. Now, when we are talking about corners on three-dimensional shapes, we are talking about a special point on a solid shape when three or more straight edges meet. So if we have a look at the cube, we can see 1, 2, 3 edges meet at the corner. So an edge is formed on a three-dimensional shape when one surface meets the other. An edge may be curved or straight. So this is one of the edges and it is straight on a cube. You may have done the home task. I'd like to share with you what I did. So I went shopping at the shape shop and I bought 3 different shapes. I bought a cube, a cylinder and a cone. Now a cube has 6 faces, so it cost $6. A cylinder has 3 faces. It has 2 flat faces and a curved surface here. So the cylinder was $3. And a cone has a flat face and a curved surface. So that was $2. And when I add 6, add 3, add 2, my total was $11. I hope you had fun shopping at the shape shop. Our learning intention today is to identify edges and corners on three-dimensional shapes. Today, when we are looking at three-dimensional shapes, we're going to be focusing on corners and edges. Now, another mathematical name for corners is vertice or vertex. Now, I have a game here. Hiding under the cups are 3 different three-dimensional shapes. Now, I'm going to read the clue and you have to try and guess what three-dimensional shape is hiding under the cup. Are you ready? Okay, let's start with this one first. I'm going to take the clue. So, this three-dimensional shape has 2 faces, 1 curved surface, 2 edges, and no corners. So it's got 2 faces, a curved surface, and 2 edges. What do you think it could be? Have a guess. Did you say cylinder? 2 faces, 1, 2. A curved surface and 2 edges. Okay, well done. Let's put that down because we've discovered that three-dimensional shape. Let's do this one. Okay, so the shape hiding under this cup has 6 square faces, 12 edges, and 8 corners. What do you think? 6 square faces, 12 edges, and 8 corners. What could it be? Say it now. Did you say cube? 6 square faces, 1, 2, 3, 4, 5, 6, 12 edges, and 8 corners. Well done. And the final one, let's read that together. Okay, this three-dimensional shape has 4 faces, 6 edges, 4 corners, and it has a triangular base. That's a clue there, a triangular base. What could it be? Let's see. It is a triangular-based pyramid. So we have 1, 2, 3, 4 faces, 6 edges, and 4 corners. Well done, everybody. I'm just going to pack this up and get ready for the next activity. Now let's take a closer look at corners and edges on three-dimensional shapes. So edges are formed on three-dimensional shapes when one surface meets the other. An edge may be curved or straight. So let's have a look here. We can see one face here and one face here, and this is the edge where the two faces meet, and these edges are straight. And a corner is a point on a solid shape when 3 or more straight edges meet. So the corner on the cube is here. We can see 1, 2, 3 edges meeting. Now, to explore the idea of corners and edges, I'm going to use some materials to make a skeleton of some three-dimensional shapes. So to start with, I'm going to make a triangular-based pyramid. So let's just have a look. A triangular-based pyramid, which is this one, it has 4 faces, 1, 2, 3, 4. It has 4 corners, 1, 2, 3, 4, and it has 6 edges, 1, 2, 3, 4, 5, 6. Now I'm going to use these wooden sticks and some blue tack to make this pyramid. So I'm going to start with the base. So I know that I need 3 sticks to be the edges. So I'm going to use a little bit of blue tack to join them together. There we go, that one's joined together. And that one. So these edges are being joined by the corners. So there's our triangular base. Now, let's build up. Put a bit of blue tack here. Oh, and another edge. And finally, one more here. Now, let's just check to make sure the attributes are correct. So, we have 4 corners. 1, 2, 3, 4. And there needs to be 6 edges. Let's check. 1, 2, 3, 4, 5, 6. Okay, so that's our triangular-based pyramid. Let's try another pyramid. Let's try this time a square-based pyramid. Okay, so that was our triangular-based pyramid, and this is our square-based pyramid. So a square-based pyramid has 5 faces, 5 corners, and 8 edges. So I'm going to use the sticks. Let's have a go. I'm going to start with the base. So I know instead of 3, I need 4 this time. Okay. Let's join those together. Got 2 edges here meeting. And a bit more blue tack on the bottom. One there. And one here. Let's join those together. So there is our square base, and let's turn it into a pyramid now. There's 1 and 2. Join that together. And 3. Oops, now I need 1 more stick. Here we are. Pop that there. Okay, there's our skeleton. Now let's just check. we need 5 corners. Count with me. 1, 2, 3, 4, 5. And we need 8 edges. 1, 2, 3, 4, 5, 6, 7, 8. So there is our square-based pyramid. Okay, one more this time. Let's try a cube. Now, I've got some pipe cleaners here that I'm going to use to make the cube. So the cube has 6 faces, 8 corners, and 12 edges. So this is what a cube looks like. Now, to start me off, I have just made 2 squares because I know that each face on a cube is a square. So here are 2. Okay, now let's connect these 2 square faces. So I'm going to hook and hook this on here. And let's join these 2 together like that. Now you'll notice that pipe cleaners are a little bit bendy, so it's not an accurate cube, but this is just a representation of a skeleton of a cube. Then let's wrap that on. So these are representing the corners here where our edges are joining. Here we go. This one. Okay, so let's have a look. So we know this is just a representation. So 8 corners, we've got 1, 2, 3, 4, 5, 6, 7, 8. And the edges we have 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. There are our skeleton representations of 3-dimensional shapes. We've made a cube, a square-based pyramid, and a triangular-based pyramid. Now your home task is to find a 3-dimensional object and count the number of corners and edges. Don't forget to record your work. Now in this lesson, we have compared the number of edges and corners on 3-dimensional shapes. We know that cubes have 8 corners and 12 edges. Square-based pyramids have 5 corners and 8 edges. Triangular-based pyramids have 4 corners and 6 edges. I wonder if you have noticed any of these shapes in your world. Thanks for joining me. I'll see you next time.